Hello, guys. I'm Nikolay Volf. I will be presenting Gear to you. I'm not very much a conference visitor myself, let alone speaker, but here anyway. It's like a very big event, and we need to get people on every one of these locations, so I'm the one here. So what would be like Gear is a modern way, so to speak, modern approach for Polkadot smart contract platform. And what is modern anyway? So modern, by modern we mean parallelizable, shardable, future-proof, such all the good stuff. So Gear does it. So Gear does it by introducing Gear protocol. Protocol might be a little bit overused word, but it's just a set of rules. What entities we keep on the chain, how do they communicate with each other, and basically a definition of what's going on our platform. Because unlike typical app-specific chain, Gear allows anybody to come and upload some piece of code on our platform, and we still don't know in that what this piece of code will do. Still need to run it securely and fast and fast. And so to achieve that, we kind of have some design decisions on our protocol. And this is our design decision. So first of all these pieces of code that exist on the Gear chain and the Gear protocol, they kind of actors in the actor model for communication. So they are communicating with each other by using messages and just that. Next, we use WebAssembly as all programs are represented as WebAssembly programs, and obviously, many people know that while working in pirate technologies, we were always was betting on WebAssembly as a virtual machine of choice for decentralized computations. And also, last, we have a persistent memory approach, which kind of removes a lot of complexities and makes the platform easy to develop on. So in Gear protocol, everything really is an actor. So programs, users, cross-chain endpoints, bridges, everything, any program you upload, once instantiated, it becomes an actor. So any parachain, any bridge, everything becomes an actor. And we sort of kind of unite everything into a synchronous framework. And all communication between them are always asynchronous. But still they're kind of logically guaranteed to be handled at some point of time. They might be handled with an error, but this error will still come at some point anyway. So this kind of provides a unified asynchronous programming experience where you don't need to care what other party you communicate with while developing your application. DAO can be a member of another DAO. Another parachain can also be a member of the DAO along with some users. And they can be of some part of programmable multi-sig contract. And it's really great for network composability. And actor model really, it's like well-established field of computer science where it's known to be good for distributed and parallelizable computations. So in blockchain, anyway, it doesn't need to be distributed because everybody obviously shares one state. But it doesn't need to be this way. Because actually using this model, we can actually store only some part of the state on each collator or validator. And we obviously use WASM. So when it comes, watch programs, aka actors, should be represented it's hard to find more modern ways than WebAssembly itself because it was designed just for this case to be deterministic and deterministic virtual machine, and also have a native speed. And yeah, it was like a big corporation of big players. They were developing this virtual machine for browsers. And in browsers, they had exactly the same case. Like you have a browser and a virtual machine inside it, and it should be able to run anything that anybody generates and still do it securely and natively without knowing in advance what this computation would be. And adoption also of single-pass compilers these days. We have a WASMer really drives things forward, where you have bytecode in deterministic that is deterministic across all platforms. And then you get native binary in one go, and it's really great for untrusted code execution, where you also must have linear time compiling these things. And no surprise that Polkadot itself uses WebAssembly, like Polkadot runtime is just a WebAssembly program. Every parachain is a WebAssembly program. And so last but not least, persistent memory approach is another novelty we bring to the table. So whereas having WASM and actor model, protocol dictates what actors should like as communicating entities, persistent memory removes many complexities and maps running programs and their state closer to operating system primitives, even hardware primitives. And memory allocation and deallocation is done page by page. And these are first-class system calls of the protocols of the gear runtime. And memory access is also tracked, like every time program needs to access some of its own memory, it's tracked and it's dispatched as a storage read, and then kind of once it's write something, it's also tracked, and only some small portion of the memory is modified. So we kind of do some tricks with virtual memory and such. So and that also really allows like any heap allocation structures be preserved. And if you know Rust and Rust futures, for example, they also once heap allocated, the whole state they're preserved, and you can have a control flow preserved, like because we have there is a possibility to like a post program execution. They can start from some place that is also preserved. Once we have this gear protocol and it's already kind of feature complete and we're kind of auditing it, we really want to deploy it in multiple scenarios. So our like a grand goal is to provide utility for the Web3, and it can be achieved in a variety of ways. And to achieve that, we deploy it at multiple scenarios. So first of all, Standalone Network, which is kind of most performant, has the least latency and such. And also we go for one or multiple slots on Kusama and one or multiple slots on Polkadot. And our Standalone Network and the chain candidate is launching any week now, while we see it mostly as a kind of test bed for kind of optimizations, for testing our protocol and such. It still has a lot of utility, and utility probably of most performant standalone networks like near Solana, and even more of that because of our parallelizable architecture. And once it's live, you can remove all our governance from there and let it like run forever, and we'll guarantee that it will never stop. We will never lose any user data and such things. So it will become actual network with utility. And it probably will have little or no governance just because we don't want to bother with governance. And we also deploy as one or multiple parachain slots on both Kusama and Polkadot. And I obviously don't need to sell Polkadot for you guys here. But still remind you, interoperability is a thing where Polkadot really shines. And we will have like all connections to other parachains, like to first the most big ones, made into a built-in gear program, which you can communicate with. Like you do it with a regular smart contract, but you will still kind of communicate with other parachain, bridge, or whatever there is on Polkadot, or whatever is coming on Polkadot. So shared security is another great thing about that. So once we deploy a gear protocol on Polkadot, it will immediately become secured by the whole network as a whole. So and also, obviously, Polkadot is a huge ecosystem. Substrate is a kind of masterpiece of decentralized software. And we want to add another piece of infrastructure to that to allow easily to deploy on the whole Polkadot just by writing like 10 lines of code and to spend like pennies. And really, there is ongoing battle for adoptions between different networks. It's ongoing, and I expect it to be increasing much more in the nearest future, especially in current conditions. And really, if you kind of see this big picture, where crypto developers are just a very small part of the whole kind of developer guys out there in the world, and it's a good thing not to cannibalize on this small part of developers by introducing some legacy execution platform like Solidity or something. But really, it's good to outreach these big circles over there, where we make programming experience as close to traditional programming as so they can as easy develop for Web3 as they do it for Web2, and this is kind of our long-term goal in Gear. And really, we are people-first company. We spend like all of our money on people, on salaries, on retreats, on everything like that. And obviously, if you are a good engineer, feel free to reach me out. Yeah, here are our links. Feel free to follow them. I will leave them there and answer some questions if there are. Where is our question guy? Huh? Where is Emily? We have any questions?
Yes, we do. Would Gear, or does Gear support trusted execution environments?
Which execution environment?
Trusted execution environments, TEs.
Like you mean no, we don't yet support it. So you don't really have any plans for doing it.
And this person said they missed the first half, so maybe you answered it. But how does Gear compare to any runtime implementing contracts palettes?
Yeah, so like there is one implementation of smart contracts which is called Ink, and it's developed in Parity, and many kind of parachains try to, add it as a palette to the network. But it has completely different execution model, whereas Ink is more traditional, like EVM, like call model. In Gear, you have this actor model when the Gear programs really don't share any state. They can only handle messages and generate messages of their own. And this gives us things that I talked about, like parallelizable execution, shardable storage, and everything like this. So we are kind of improving on that.
Wonderful. Thank you so much, Nikolay.
Thank you. Thank you very much.
Thank you.